Ashe. I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind majestic Mind Matters University, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the attenuator. Attenuators are an essential component of any electronic system, designed to reduce the strength of a signal without significantly affecting its shape. Applied electronics technicians require a thorough understanding of attenuators in order to effectively troubleshoot, design, and maintain electronic circuits. In this essay, we will explore the different types of attenuators, how they work, and the key considerations technicians need to keep in mind when working with them. Attenuators come in various types, including fixed, variable, and digital attenuators. Fixed attenuators have a fixed attenuation value that cannot be changed, while variable attenuators allow the user to adjust the attenuation level. Digital attenuators, on the other hand, are controlled by digital signals and can be programmed to provide precise attenuation levels. Each type of attenuator offers unique advantages and is suited for different applications. The basic principle behind attenuators is to dissipate a portion of the signal power as heat, thereby reducing the signal strength. This can be achieved through various methods, such as resistive or reactive attenuation. Resistive attenuators use resistors to dissipate signal power, while reactive attenuators use capacitors or inductors to redirect signal energy. The choice of attenuation method depends on the frequency range and required performance specifications of the circuit. When working with attenuators, technicians must consider several key factors to ensure proper functionality and performance. One of the most important considerations is the attenuation level, which is typically measured in decibels dB. The attenuation level determines how much signal strength will be reduced and is crucial for maintaining signal integrity. It is important for technicians to select the appropriate attenuation level based on the input and output signal requirements of the circuit. Another important consideration is the insertion loss of the attenuator, which refers to the amount of signal power lost when the signal passes through the attenuator. Lower insertion loss is desirable as it indicates better signal transfer efficiency. Technicians must carefully evaluate the insertion loss specifications of attenuators to ensure optimal signal performance in the circuit. Impedance matching is also a critical factor to consider when working with attenuators. Attenuators must be matched to the input and output impedance of the circuit to prevent signal reflections and ensure maximum power transfer. Technicians should pay attention to impedance matching requirements when selecting attenuators to avoid signal degradation and ensure smooth signal transmission. In addition to these factors, technicians should also be aware of the bandwidth limitations of attenuators. Attenuators have specific frequency ranges over which they operate effectively, and exceeding these limits can result in signal distortion or loss. Technicians must carefully review the bandwidth specifications of attenuators to ensure compatibility with the circuit's frequency requirements. Furthermore, technicians should be familiar with the different types of connectors and packaging options available for attenuators. Attenuators can come in various form factors, such as surface mount, coaxial, or waveguide connectors, and technicians must choose the appropriate connector type for seamless integration into the circuit. Attenuators play a crucial role in electronic systems by reducing signal strength while maintaining signal integrity. Applied electronics technicians need to have a deep understanding of attenuators, including the different types, working principles, and key considerations for selection and integration. By being knowledgeable about attenuators, technicians can effectively design, troubleshoot, and maintain electronic circuits to ensure optimal performance and reliability. Attenuators are essential components in many electronic systems, serving the purpose of reducing the amplitude of a signal without significantly distorting its waveform. They are used in a wide range of applications, including communication systems, test and measurement equipment, audio systems, and more. Understanding the different types of attenuators available, such as fixed, variable, and digital attenuators, is crucial for applied electronics technicians to effectively design and troubleshoot electronic circuits. Fixed attenuators are passive devices with a fixed attenuation value that cannot be changed. They are designed to provide a consistent level of signal reduction across a specific frequency range. Fixed attenuators are commonly used in applications where a constant level of attenuation is required, such as in signal alignment, impedance matching, and power reduction. These attenuators are available in various configurations, including pad attenuators, T attenuators, and pi attenuators. Variable attenuators, on the other hand, allow the user to adjust the attenuation level according to the specific requirements of the application. These attenuators typically consist of an attenuator element, such as a potentiometer or pin diode, that enables the user to vary the attenuation level by changing the resistance or capacitance of the circuit. Variable attenuators offer greater flexibility compared to fixed attenuators, as they allow for precise adjustment of signal levels in real time. They are commonly used in applications such as signal conditioning, gain control, and signal level adjustment. Digital attenuators are a newer type of attenuator that is controlled by digital signals, allowing for precise and programmable attenuation levels. These attenuators typically consist of a digitally controlled attenuator element, such as a digitally controlled potentiometer or a digital step attenuator. Digital attenuators offer the advantages of remote controllability, precision adjustment, and repeatability. They are commonly used in applications where precise control of signal levels is required, such as in automated test systems, communication systems, and RF signal processing. Knowing the characteristics and capabilities of each type of attenuator is essential for applied electronics technicians when selecting the most appropriate attenuator for a specific application. Fixed attenuators are ideal for applications where a constant level of attenuation is required, such as in power distribution systems or signal conditioning circuits. Variable attenuators are suitable for applications that require adjustable signal levels, such as in audio systems or RF communication systems. Digital attenuators are best suited for applications that require precise and programmable signal attenuation, such as in automated test equipment or radar systems. In addition to understanding the different types of attenuators, applied electronics technicians should also be familiar with the key parameters that characterize the performance of attenuators. Some of the important parameters to consider when selecting an attenuator include attenuation range, insertion loss, return loss, and frequency response. Attenuators with a wide attenuation range and low insertion loss are preferred for applications where signal attenuation is critical, while attenuators with high return loss and flat frequency response are ideal for applications that require signal fidelity. Attenuators play a crucial role in electronic systems by allowing for the precise control of signal levels. The different types of attenuators, including fixed, variable, and digital attenuators, offer unique advantages and are suited for different applications. Applied electronics technicians need to have a thorough understanding of attenuators and their characteristics to effectively design, troubleshoot, and optimize electronic circuits. By knowing the various types of attenuators available and their key parameters, technicians can select the most suitable attenuator for a specific application and ensure the optimal performance of the electronic system. Applied electronics technicians play a crucial role in the design and maintenance of electronic circuits, systems, and equipment. One important concept that technicians should be familiar with is the use of attenuators. Attenuators are devices that are used to reduce the strength of a signal while maintaining its waveform. Understanding the basic principles behind attenuators is essential for technicians to effectively design and troubleshoot circuits. The basic principle behind attenuators is to dissipate a portion of the signal power as heat, thereby reducing the signal strength. This can be achieved through various methods, such as resistive or reactive attenuation. Resistive attenuators use resistors to dissipate signal power, while reactive attenuators use capacitors or inductors to redirect signal energy. Resistive attenuators work by introducing a resistive element into the signal path, which absorbs some of the signal power. The amount of attenuation can be controlled by varying the resistance value. A common type of resistive attenuator is the voltage divider network, where two resistors are connected in series to divide the input voltage. By adjusting the ratio of the resistances, the output voltage can be attenuated to the desired level. Reactive attenuators, on the other hand, use reactive components such as capacitors or inductors to redirect the signal energy away from the output. This is achieved by creating a reactive network that absorbs or reflects certain frequencies while allowing others to pass through. Reactive attenuators are commonly used in RF and microwave applications, where precise control over the frequency response is required. The choice of attenuation method depends on the frequency range and required performance specifications of the circuit. Resistive attenuators are suitable for low to moderate frequencies, where power dissipation is not a major concern. Reactive attenuators, on the other hand, are more suitable for high-frequency applications, where power handling capabilities and frequency response are critical. In addition to selecting the appropriate type of attenuator, technicians must also consider the impedance matching requirements of the circuit. Attenuators should be designed to match the input and output impedance of the components they are connected to in order to minimize signal reflections and ensure proper operation. Another important consideration for technicians is the insertion loss of the attenuator. Insertion loss is the reduction in signal power that occurs when the attenuator is introduced into the signal path. The amount of insertion loss depends on the attenuation level and the characteristics of the attenuator components. Technicians should carefully calculate the insertion loss of the attenuator to ensure that the desired signal level is achieved at the output. In practical applications, attenuators are used in a wide range of electronic systems, including communication systems, test and measurement equipment, and audio devices. They are commonly employed to adjust signal levels, improve signal quality, and protect sensitive components from damage. In conclusion, applied electronics technicians need to have a solid understanding of the basic principles behind attenuators in order to effectively design and troubleshoot electronic circuits. By knowing how attenuators work and the different types of attenuation methods available, technicians can make informed decisions when selecting and integrating attenuators into their designs. By considering factors such as impedance matching, insertion loss, and specific design requirements, technicians can ensure that attenuators function as intended and contribute to the overall performance of the circuit. Thank you for participating in this majestic Mind Matters University Basic Applied Electronics Information session. We appreciate your engagement and sincerely hope that this information will help propel you to a better understanding of basic applied electronics. Like, subscribe, and share to stay updated on our upcoming sessions and help spread knowledge in electronics. The title for this basic applied electronics session was Introduction to the Attenuator. Ashe.